Welcome friends, I am Mr. Harshal Warade, Assistant Professor from Sanjeevani College of Engineering, Kopargaon. Let us learn today the new part, Interferometers Part 2 from the Advances in Metrology Unit 3. So in previous lecture we have seen the NPL flatness interferometer. Today we will see NPL gauge length interferometer or Pitter-NPL gauge interferometer. So I have shown a figure of Pitter-NPL gauge interferometer. The Pitter-NPL gauge interferometer, it basically consists of a collimating lens, a constant deviating prism, a base plate on which we can keep the object for measurement purpose. An optical flat is also provided with the gauge interferometer. There is one viewing aperture and reflecting prism mechanism and illuminating aperture. The condenser lens of the Pitter-NPL gauge interferometer condenses the light rays which come to condenser lens, and finally it is incident from the monochromatic light source. So let us see, this interferometer is generally used for determining the actual lengths of slip gauges. The illuminator provides a concentrated light source. A concentrated light source is generally monochromatic light source. Monochromatic light source is nothing but the light source having single color. Mono means single, chrome means color. So single colored light is only incident, it is used in this NPL gauge interferometer. So working of this interferometer, light from a monochromatic source, the preferred light source is a cadmium lamp, is condensed by a condensing lens and focused onto an illuminating aperture. This provides a concentrated light source. Thus a parallel beam of light falls on a constant deviation prism. This constant deviation prism splits the incident light into light rays of different wavelengths and hence different colors. The user can select a desired color by varying the angle of reflecting faces of the prism relative to the plane of the base plate. The prism turns the light by 90 degrees and directs it onto the optical flat. The optical flat can be positioned at a desired angle by means of a simple arrangement. The slip gauge that is to be checked is kept right below the optical flat on the top of highly flat surface of the base plate. The lower portion of the optical flat is coated with a film of aluminium which transmits and reflects equal proportions of the incident light. The light is reflected from the three surfaces, namely the surface of optical flat, the upper surface of the slip gauge, and the surface of the base plate. The light rays reflected from all the three surfaces pass through the optical system again. However, the axis is slightly deviated due to the inclination of the optical flat. This slightly shifted light is captured by another prism so that the fringe pattern can be observed and recorded by the user. So this is what is the field view of the fringe pattern which is obtained when we are employing or applying the Pitter-NPL gauge interferometer. So it can be seen that the two sets of the fringes are displaced by an amount A with respect to each other. The value of A varies depending on the color of the incident light. The displacement A is expressed as a fraction of the fringe spacing B, which is as follows: F is equal to A divided by B. Now let us learn the second part in it, that is lesser interferometers. So in the figure I have shown a lesser interferometer and the arrangement for lesser interferometer. The lesser interferometers can be used for measurement of small diameters as well as large displacements. Working. Light or lesser light is first of all on the semi-reflector plate P, which is partially reflected by 90 degrees and falls on another reflector S. A portion of light passes through P and strikes the corner cube. Light is turned through 180 degrees by the corner cube and recombines at the semi-reflector plate S. If the difference between these two paths of the light, that is PQRS-PS, is an odd number of the half wavelengths, then the interference will occur at point S and the diode output will be at a minimum. On the other hand, if the path difference is an even number of half the wavelengths, then the photodiodes will register maximum output. Each time the moving slide is displaced by a quarter wavelength, the path difference PQRS-PS or minus PS becomes half a wavelength, and the output from the photodiode also changes from maximum to minimum or vice versa. So this is what is the working of laser interferometer. And here are the few references which you can refer for further reading of this topic. Thank you.